Let's work a problem. Sample problem 1. Starting from rest, so what is that telling you? That your initial velocity is 0. An object accelerates at a rate of 2.4 meters per second squared. It ends up with a speed of 14.4 meters per second. How long did it accelerate for? So let's follow our steps. Read the problem carefully, or listen to the problem carefully because I was reading it. Draw a sketch if necessary. Not really required here. Let's list our variables, any constants, and the variable you're solving for. Starting from rest, showed that on the last slide, that means v0 is equal to 0. Here's your acceleration, which is a constant acceleration. That's the only ones we'll deal with. Ends up with the speed. Those are fancy words for your final velocity is 14.4 meters per second, and we need to find time. So you can write them on your paper or your screen, however you're doing this. v0 is 0. v is 14.4 meters per second. Here's your acceleration, and time is equal to, well, that's what we're going to figure out. Select an appropriate equation to use. So here's our givens, along with what we're trying to find. What equation will match these variables? It may help to check if you have x and t listed as variables. Well, let's see, do I see an x? No, I don't see an x. But time is listed there. I mean, that's what we're trying to find. So we're going to use v is v0 plus at. Right? Here's v, here's v0, here's a, and here's t, which is what we're looking for. Okay, here we go. We start with the equation we selected, which is kinematics equation 1. v0 is equal to 0. Gets rid of that. So now we have v is equal to at. But we would like to solve for t, so we got to get t all by itself. So let's divide both sides by a. So you'll see a cancels out here. It stays on the left side. So we have v over a is equal to t. And we can always reverse the equation here, right? So v over a equals t. That's the same as t equals v over a. So here we have t is equal to v over a. Notice we didn't put units in there. Pretty much we've got v over a, just leave it like that. And then at the end, when we put our numbers in, we'll make sure the units check out. We don't want to do too much writing, right? We could have written that as t in seconds is equal to v in meters per second. And you can see how long this is taking us, right? We don't have to do that. As long as you're using the right equation and you do the algebra right, you're okay. And it'll check out at the end. So here we go. T, the velocity, is 14.4 meters per second. Here's our acceleration. And we divide through. We get t is equal to 6 seconds. So here we go. Your units will come out correct if you do the problem correctly. And including your units in your calculations can help you spot mistakes. But I think in this case we can just put it in at the end and we'll be okay.